In this video, we'll be talking about the correlation coefficient R. That is in reference to a scatter plot. So when we have a scatter plot, for example, if I look at this example right here, I see a positive trend and I see that the points are going up to the right, so it's a positive correlation. In addition to positive correlation, we have a strength of correlation. We'll get to it as we go on. So the correlation coefficient is a strength of the correlation, and it again relates to a scatter plot. What is a scatter plot? We have a relationship between two quantitative variables, in other words, x and y. The values of the variable appear on the horizontal, which is the x-axis, and the y-axis on the vertical. Each individual in the data appears as a point on the graph. So after we plot the ordered pair, we have the points on the graph. How to examine a scatter plot? As in any graph, we look for all overall pattern. So in this pattern, we can observe a positive trend. The overall pattern of a scatter plot can be described by a direction. So we have positive direction. A form, linear in this situation. The trend is close to a line. And then we have strength. So that is our new part of the scatter plot. Strength of the relationship. An important kind of departure is an outlier. So outlier is an individual value that falls outside overall pattern. So like right here, it's like, what's wrong with you? Everybody is in a trend, everybody is going this way, and what happened to you over here? So this little weirdie is outlier. Then what we can create based on the trend is observe again the trend being a linear of let's say pattern, and then we create the line of the best fit, and this is a line drawn through the maximum number of points on the scatter plot, and you just kind of want to balance evenly, but not necessarily perfectly evenly, but following the trend create a line that kind of represents that pattern or the growth, or if it goes down to the right, what would be that line that is the best fitting representation of the trend. So a line of the best fit is a line drawn through a maximum number of points on the scatter plot, balancing about the equal amount of points above and below the line. So we can see how the growth is of the line, and if it's a negative trend, we can kind of size it up. Another thing we need to talk about is the correlation coefficient. So check this out. I have a few examples that I put side by side here. This one's up top. Let me make sure that we can see all of them. In the first example, I have a positive correlation, and look the strength. In other words, the points are very close to representing a line. So they are close together. So this is a perfect or a very strong positive correlation. Now, if they start spreading out a little bit, you still can see that line, but they're not as close together. So they start spreading out a little bit. That's still good correlation. It's on the higher side. I would kind of go past like 3/4, 0.75 to perfect 1 or to perfect perfect correlation. So this one is going to be high, kind of good, and still positive. Then in the next example, I have low. So this is like up to around 0.5, let's say 0.6, 0.4. So low or weak, and it is still positive because I can observe a trend here. It's not fully no correlation yet, but it's very, the points are spread out more. And once they get all spread out, and I can't even tell if it's up or down, that is zero correlation or no correlation. And then we go downward, see how the points are just spread out, but I do observe a negative correlation, but very weak, so they're way spread out. Then they kind of get closer together in a higher or good, still negative correlation. But these ones are almost like a perfect straight line going negative down to the right direction. So the perfect strong negative correlation. So the type or the strength of the relationship is either perfect one, it's like 100%, perfect one, and as close to a straight line as it can be. So the points will be close together. Then in the high or good positive, could be like a number that it's around past, let's say, 0.7 or like 70%-ish kind of type. Then we have a weak or a low positive correlation, maybe around 0.4, 0.5, up to like 0.6. So thinking about like percentage-wise, would you like a 50% score? And no, that's low, that's weak, right? Zero correlation, that's when you can't even tell if it's up or down, and the points are just spread out and there is no correlation. But then when we get to the negative side, again, the strongest will be -1. So -1 is the strongest negative, and the points are close together. If they're farther apart, that will be good, or let's say 0.8, 0.9, 0.75. And then the 0.5, 0.4, when it's low, you can still tell that it's going down, but it's very spread out situation. So this strength is called correlation coefficient, and it's a measure of the strength of the association being between those two variables. The coefficient of correlation is labeled lowercase r. So little r is always a number between -1 and 1. So -1 being downward direction, so it's the sign for negative down to the right orientation or direction, and positive being up. So we have the r always between -1 and 1, strongest negative orientation and strongest positive 1 orientation. Important, the values of 1 and -1 are the strongest, and the value of 0 is the weakest. So 0 is no correlation. So for example, I have a few examples of what the numbers could look like for the correlations. So if we have 1 is the strongest. So it's like 100% unit. Perfect, positive correlation. So that would be a line going up to the right. So if you see r equal 1, it's the strongest positive correlation. Then we have r equal, or the correlation coefficient, 0.75. So 0.75 is okay, it's strong, it's positive correlation because it's a positive sign, and it's okay, it's strong, it's not weak, it's okay. Then we have 0.56. Well, 0.56 is kind of weak. Like, picture yourself, do you want a 0.56 on your grade, like 56%? No, that's kind of weak or low positive correlation because it's still positive sign. Anything that is really close to 0 represents no correlation. So if we see r equals 0, no correlation. Then we go the negative side. So if the correlation is negative, it means that it's a negative trend. So the points would be going down to the right. Positive up to the right, negative down to the right. And then we see 0.4. So 0.4, which is 452, not as significant, but the first two digits or the first digit after the decimal is good enough estimate. So we have negative direction 0.4. Remember 0.4, that's weak. The next one is negative, so we have a trend going downward, and it's 0.9. 0.9 is really close to 1. In other words, it's very strong. So it's a strong negative correlation. Negative would go down because of the negative sign, and it's really close to -1. So strong negative correlation. That would be like this one right here. The points are close together, they're going negative way. And the correlation coefficient -1 is perfect negative. In other words, we go downward, very strong, close together. So we are going to, for instance, have a test question that gives us the correlation numbers. And we have to just see which of the following correlation coefficients indicates the strongest. And when you think strongest, it's either, again, close to 1 or -1. Perfect, 100%. So we want to see which ones are the strongest relationship between the two variables. So which of the following correlation coefficients, those are the correlation coefficients given, indicates the strongest relationship. In other words, closer to 1 or -1. So we have 0.3, and again, I'm looking at the significance of the first digit. Sometimes they put a lot of digits in your question just to throw you off. What you have to look at is the first digit. So we have 0.3 negative, 0.4 positive, -0.8, that's high, and 0.7, that's high. So when we look at the strength, it doesn't say positive or negative, so we always have to be careful in reading the directions. It just says the strongest. It doesn't say strongest positive, it doesn't say strongest negative, it just uses the word strongest. So we are going to look at 0.8 as the biggest value. Well, it is a negative correlation, but it's still closest to 1 or strongest. Okay, closest to a value of, in this situation, -1, because it's the bigger number, and it is going to represent the higher strength. Which of the following correlation coefficients, again, A, B, C, D are correlation coefficients, indicates the weakest relationship between the variables? So that would be the closest number to 0. What is the closest number to 0 in this situation? So if we say 0.9, that's strong. 0.2, that's weak. 0.6, that's on the weaker side, but it's getting stronger. 0.8, that's pretty strong. So we need to look for the weakest. And that would be 0.2, in other words, closer to 0, because the weak and, or let's say no correlation is the 0. So the number that is closest to 0 is the weakest. So here's what I need you to do next. You have a set of correlation coefficients. And what you're going to do is look carefully at the 6 graphs that you have, and you're going to place these correlation coefficients into the rectangles here where the R equals correlation coefficient is labeled R, and you're going to use these numbers to see what correlation coefficient goes in which rectangle for each scatter plot. We'll discuss your results in class.